Hey folks, so I got a pretty big update to the panopticon project, the image processing thing I've been working on to go through. Live video, it's processing stuff in real time. On the left-hand side, these are the images that it's reading in from my webcam on my laptop. And on the right-hand side is the image that it's generating using all the OpenCV stuff. As you can tell, this environment isn't exactly fit for anybody to live in. To say nothing of whatever fiddly algorithms are going on. I got like a green board game box up there that is setting off the thing. I got like a jacket that's doing it too. Um, but yeah, at least you can see that it's picking up green values, which I'm pretty happy with. And if I use this Yes CD that I borrowed / stole from my dad, you can see that it's able to follow stuff around pretty well. We can't see it right now because I just don't have the window in the foreground right now, but like it is doing all the calculations and stuff, but it's like it's doing it 20 times a second, so nobody can actually read it. If you're interested in that, watch the other two videos I made on this, which go into all that stuff. So there's a couple of changes to the code that I made last night that make this whole thing possible that I'm going to go over really quick. So first of all, I made a bunch of changes to the thresh RGB function. First of all, we're processing in HSV values now instead of RGB because it turns out RGB is absolutely garbage for real life images because any color that's like sufficiently light will just have a high green content, and the separation thing that we were trying to do just doesn't work with that. And there's noise all over the place from like the walls and from me and all other kinds of stuff. But by using hue for color instead, it's there's a pretty defined range that we can go through. We're also using some morphology transformations on the image. I don't really know exactly how these things work, but basically they take the kernel Campbell, which you gotta force Metal Gear Solid references into everything. That's Praxis or whatever. Um, it's using that in order to smooth out the image somewhat. So like this first one is using morph_close, which removes false negatives. So like if you have if you're holding up the CD and there's, it's mostly white, but there's a ton of like black pixels and stuff like that in there, it'll be able to clean that up and fill it in more cleanly with white. And then conversely, morph_open does the opposite. It removes false positives. So if there's like random white noise pixels all over the rest of the image that you're not trying to pick up, it'll filter that stuff out, which is very useful. And then next up, there was like, I guess there was just this edge case that it just completely slipped my mind when I was programming this thing to start with. So basically, if there's a wreath or like just an object, I guess, it doesn't really know what a wreath is. There's a wreath that exits the like the left-hand side of the frame and there's nothing following it. It doesn't know how to handle that. So or the previous version didn't know how to handle that. So right here I just have like an extra little conditional here that I'll set the new wreath flag if the last known position of an object was within the last fifth of the image. So like if something leaves and then disappears, and it's fine. It can handle that pretty well. Let's see. And the last main thing is just like the video capture thing itself, which OpenCV like handles all the legwork on this. It's pretty crazy. There's just a video capture data type, and you instantiate it with an integer that corresponds to like an index value for your camera. So I think it seems to me that it's like whatever is the most recently plugged in camera is the one that gets 0, and then it kind of counts up from there. I'm not really sure why it works like that, but that seems to be what it was doing when I was screwing around with it. So yeah, 0 just happens to be my the built-in webcam. And then from there, it's just replacing imread calls to like that the deck that's just a huge list of file names. Just replaces that with like this statement here, reading in from the camera. And that's it. That's all it took to get from simulation to, I mean, slightly more advanced simulation, but like real time stuff. And it was things able to run at like 20 FPS, which is pretty impressive. It can probably run faster. This is just like what I have it going at because it's a nice number. That's kind of what we're triangulating towards with the cameras because they get like really hot for some reason if they're shooting in like full 30 FPS, and it's not as bad if it's lower than that. So from here, we're looking at getting all this stuff onto the Jetson embedded system, and then we got to figure out how to uh, communicate like whatever we're finding here with the motor controls guys. I think one of those guys is like pretty on top of things with respect to like multi-threading and stuff like that. So I'm just gonna let them handle that. That's like way above my pay grade. Uh, and then we gotta like actually install the thing and like build like the environment with like the pink background and all that stuff. So I'm really looking forward to this. I think this project is gonna round itself out pretty cleanly, I think, which I'm excited for. It's really exciting to see this come to fruition. So I'll definitely be posting again once we get some more stuff going on.